Hello everyone, my name is Maria Jose Alonso and I'm going to present my research about the use of lignocellulosic biomass in the development of biobinders for the paving chain. In the pavement sectors, the industrial process involved in the production of petroleum-based asphalt binders demands around 40% of energy, which contributes with approximately 10% of total CO2 emissions. On the other hand, the construction materials are vulnerable to physical and chemical factors that degrade their internal structures, which generate high costs for the repair and maintenance. In the recent years, byproducts derived from biomass materials have emerged as potential alternatives to reduce the impacts caused by construction sectors. The bio-based products derived from biomass sources are named biobinders and are produced by thermochemical processes such as pyrolysis. Biobinders show physical, chemical, and rheological characteristics similar to petroleum-based asphalt binders. In this context, the main aim of this work is the use of lignocellulosic biomass in the development of sustainable biobinders for application in the paving chain. In order to realize the objective determined, the following methodology was performed. 500 grams of lignocellulosic biomass were subjected to pyrolysis process, with condition optimized by Vieira and collaborators in 2020. The fraction of bio-oils obtained were separated by decantation, and subsequently the insoluble fraction of bio-oils were characterized by FTIR analysis. In the figure 1, we can see the chemical characterization of insoluble fraction of bio-oils obtained from sugarcane bagasse and rice husks. According to previous studies of biobinders obtained from biomass materials, this analysis can be described as follows. The broad peak reflected around 3,400 centimeters indicates the hydroxyl stretching vibration that corresponding to presence of alcohols and phenols. The weak peaks reflected around 3,000 centimeters indicates the carbon and hydrogen stretching vibration that corresponding to alkane compounds. The strong peaks reflected around 1,700 centimeters indicate the carbon double oxygen stretching vibration that corresponding to ketones, carboxylic acid, and aldehydes compounds. The peak observed around 1,500 centimeters indicate the double carbon stretching vibration that corresponding to alkanes and aromatics compounds. The peak reflected around 1,400 centimeters indicates the carbon-hydrogen stretching and bending vibration that corresponding to alkanes compounds. The peaks reflected around 1,200 centimeters indicates the carbon-oxygen stretching vibration and hydroxyl deformation that signify the presence of carboxylic acids, ether, and esters. Finally, the peaks found around 900 to 700 centimeters indicates the carbon-hydrogen binding that corresponding to aromatics compounds. It can be concluded that biobinders obtained from sugarcane bagasse and rice husks are constituted mainly by phenols, alcohols, cetones, aromatics, aldehydes, alkanes, ether, and esters, which are the usual chemical compounds found on the composition of petroleum-based asphalt binders. Further, to quantify the specific chemical compounds of biobinders obtained in this study and justify the existence of the functional groups identified by FTIR analysis, these byproducts will be characterized by gas chromatography mass spectrometry analysis. Thanks for your attention.